use the graphs to determine the values of x in the interval 0 to 180. So in the interval 0 here, 0 sorry here to 180 here, where f at x divided by g of x is less than 0. What does that mean? Less than 0 means negative, right? And here we have f at x at the top and g of x at the top. If we have f at x as positive and g of x as positive, this answer will give us something that is positive, right? Do we agree? This will be positive. If we have f at x as negative and g of x as also negative, this answer will also give us something that is positive, because negative and a negative, you get a positive. However, if one function, say f at x, is negative and the other, say g of x, is positive, you will get something that is negative, which is what we are looking for in the question. And if f at x is positive and g of x is negative, we will also get something negative. So what does this mean? F at x being positive, f, this function, if it's positive, it means it's above the x-axis, right? It's above the x-axis. And the same thing goes for g. If g is positive, it means it's above the x-axis, because the y values above the x-axis are positive. These are all positive y values. If f at x is negative, that means f at x is below the x-axis, so as well as y. So here f at x is above the x-axis, therefore f at x is positive. But here f at x is below the x-axis, so f at x is negative, and so on. Now let's look at our analysis again. If f at x and g of x are both positive, that means they are both on the same side of the x-axis and they are both on top, right? If f at x is positive and g of x is positive, that means they are both on the same side. I'm going to teach you how to do this problem generally, not just this one. So it means that f at x and g of x are both on the top or on the above the x-axis. And if f at x and g of x are both negative, that means that g of x and f at x are both below the x-axis, because that's where the y values are negative. Now, we want somewhere where f at x is negative and g of x is positive, or f at x is positive and g of x is negative. What does that mean? They should be on different sides of the x-axis. They shouldn't be on the same side, right? Because if they're on the same side, you get something positive. So Tina, we want them to be on different sides. So that's where we are going to find our answer. So to find these answers, what you do is you find where the graphs cross the axis and draw dotted lines. That will make things easier for you. I will analyze the part that is out of the range we are looking for as well, just so that you guys get to understand how to answer the question. And then I'll only write the answer to the question though. This is where GF cuts the x-axis, therefore I put a line there. I put a dotted line here too, where F cuts the x-axis once again. Here G cuts the x-axis, and therefore we should put a line there too. Here F cuts the x-axis once again, and here G cuts the x-axis. You put lines everywhere where functions cut the x-axis. Now let us use our analysis. From the analysis, we know that both graphs have to be on different sides. They have to be on different sides, right? I'll start here, even though we don't need that for the answer. Here, f is positive and g is negative, right? Because g is below the x-axis and f is above. And therefore, if we were allowed to use this range, this would be our first answer, from negative 180 to negative 90. Okay? However, here in this range, g is negative and f is also negative. Now they are both on the same side. Therefore, this range we would not include in our answer because they are on the same side. On the next range, f is negative. F is negative there, but g is positive because g is above the x-axis. So that means we would also include this on our answer because we want them to be on different sides. One should be above, one should be below. And here one was above and one was below. But we don't include this. So let's go to this part. Some people like to say to put pluses to show negative, positive, and put negatives to show negatives. So let's do that. Maybe it's also going to help. Putting negatives there because it's below the x-axis. Put negatives there because it's below the x-axis. But put positives there because it's above the x-axis and therefore that function is positive. And this one is positive there. Okay, now let's look at f. F is positive here as we wrote the positive signs, but g is also positive there. G is also positive up to here on this range. So they are both positive and therefore we should not include this in our answer. But this next range, we have g still positive and f is negative now. F is negative. If f is negative, which is below the x-axis, and g is positive, that means this should be included in our answer. So that's our first solution in the range. This from 90 to this value here, which we will find to be 135 degrees. And then here we have f below the x-axis and g also below the x-axis. So they are both below the x-axis, therefore we do not want this answer. Therefore this is our only answer. That's our only answer for this question. The range is from 90 to 135. That's why it's only 2 marks. But I had to explain in detail so you guys can understand that, because I know it's a tricky question and it's usually there. So our answer should be x, they're using x, né? Yeah. X should be greater than 90 degrees but less than 135 degrees. Right, so why is this 135, you might ask? One answer would be you could use transformations, because this on the original cosine graph would have been at 90, and we know that this graph shifted 45 degrees that way to form the new function, which is cos minus 45. So you just take 90 and add 45 degrees to get this point. Or you could say you could take this function and equate it to 0 to find the intercept, and you are probably going to get 135 as one of your solutions. another way, no, that's enough ways. Let's move on. So for x in the we are done with this one, we're moving to this one. So for x in the interval 0 to 180 degrees, where sine 2x is greater than or equal to this. Right, so if they write something that resembles a function this side, because we know this is f at x, and on that side they write something that looks messy, especially if they took out a common factor that looks like a special ratio or special angle ratio, then you know you should change this somehow to turn into one of the functions. So what we are going to do is we are going to take we have sine 2x greater than or equal to 1 over square root of 2 into sine x plus cos x. What we're going to do is we're going to distribute the 1 over 2 over the other thingies. So we have greater than or equal to 1 over square root 2, 1 over square root 2 sine x plus 1 over square root 2 cos x. This we know to be cos 45 degrees. Cos 45 degrees is 1 over square root 2. But also sine 45 degrees is equal to 1 over square root 2. So you have to pick between these two, whether to substitute here. What I'm going to pick is, I'm going to pick strategically according to what information we have already been given on the question paper. But I'm sure even if you picked in a different way, you would get to the answer. So we want to get this function. If we were to change this to be sine, so if this was sine 45 and this was also sine 45, we would have a hard time trying to simplify that, because we'd have sine 45 here, sine 45 there. It's sine cos. That doesn't have anything we know. But if we put cos here and we put sine there, we would have sine cos and cos sine. That would be a double angle for sine. But this is not sine. So that would work, but you would go a longer path trying to find the answer. What I will use is I will use cos next to cos, and I will use sine next to sine. That way I have cos, sine, which will be the double angle for cos. But let me rearrange a bit. I'll start with this term. I'll say cos x multiplied by 1 over square root 2. Right, this is exactly this. I wrote it here. Plus sine x multiplied by 1 over square root 2. And that is exactly that. Now what I will do is I'll say cos x. In the place of this I substitute cos 45 degrees. Plus sine x. In the place of this I substitute sine 45 degrees. Right, now greater than or equal to. You should probably keep writing this all the way down here. Now you have cos, sine, cos, sine. That's a double angle for cosine. And it says x minus 45 degrees. Because for cos, if it's plus here, you change it to minus. And you know that this is compared to sine 2x. Right, so now sine 2x you know to be f at x. And cos x minus 45 you know to be g of x. So you look at where g of x is greater than or equal to f at you look at where f at x is greater than or equal to g of x. What does that mean? If a function is greater than another one and they're on the same axis or same Cartesian plane, that means that that function is above that, or the one that it is greater than. So what do I mean? If f at x is greater than g of x, that means g of x is above f at x. G of x is above. It's like if you have two lines like this. At this point, let's say this was h of x and this was z of x, and this was 5. At 5, h of x is above. It's above z of x. Therefore, at 5, h of x is greater than z of x. So let's go look at the question here. Where is g of x? Where is f at x greater than g of x? This is f, but we have to look at the interval from 0 to 180. So from here, the critical point will be the intersections. The critical point will be the intersections of the two functions. So this is another intersection. This is another intersection, and this is not an intersection. It's the beginning of the range we're allowed to use to analyze. Right, from here, what is this function? This function is f, and it's below. This is f, and it's below g. F is under g. That means this is not the part we want. This is not the part we want. Since we want g to be at the top, we want g to be the one above or equal to. If you go up to this intersection, at this intersection, they are both equal because they are at the same point. If they are equal, that means that's one of your solutions, where x is equal to 45 degrees. It's equal to 45 degrees because the cosine graph shifted 45 degrees to here. Or you can say the maximum of this function will still be at 45 degrees because we did not multiply anything into the the maximum of the original sign was at 90, and so you divided it by 2 because this divides the period and it divides every value you have. So you say 90 divided by 2, you get 45. Okay, so that's 45 degrees. Your first solution here is x is equal to 45 degrees. It's equal to, you don't use any inequality because it's at a point, it's not a range. Because once you come to this side again, you see that we want f to be above, but f is still below, so you don't include this. F is still below. You see, even here, f is still below, and g is above, up until this intersection. At this intersection, we know that f, which is this one, starts to be above. You see g of x is at the bottom now. That's exactly what we wanted, because we wanted f at x to be greater than g of x or equal to g of x. So this from here to 180, that's the second range, that's the range we want, and we don't know what the point is here today. So what are we going to use to find what the coordinates are here? We are going to use our general solution, the one we found before. Where is it? Oh yeah, here it is. So we'll use this general solution because this general solution is the general solution for the intersections of the two graphs or two functions. So if we substitute different values of k, we should get to the value of k that it is at that point. So we say 45 degrees plus 120 k. That's our general solution. Now we substitute different values for k. Let's start with 1. That's exactly what we want, because check it, this is a point where it's greater than 135 but it's less than 180. This is exactly the answer. So it's 165. This point is 165. Okay, so I feel like I'm talking too much and it's not making sense anymore. Basically, the range we want is from 165 to 180. So what we're going to do is we're going to say x is greater than or equal to 165, or x is less than or equal to 180. And the reason why we close it at 180 is because they specified that we have to end at 180. We can't exceed that. So this is your final answer for this one.